Okay, great. Welcome. Thank you all for braving the storm out there to come inside and talk about bees. Bees are a topic that's near and dear to my heart. I worked in the insect research for about 7 years. Are we gonna have an introduction here, or you wanna just sit in? Okay. So yeah, anyways, my name is Blake Dinius. I worked in insect research for about 7 years, and that included a lot of work with bees. Some of that work is now being used to basically to guide studies that are being used worldwide. So this is, anytime I get a chance to talk about bees and teach people about them, about something that I love, I'm gonna jump at that opportunity. So I hope that when you all leave here, that you also have an appreciation for bees as much as I do. However, I do like to talk about, what it is we're fighting for. Because sometimes when I look online or I see things being passed around on the internet or Facebook, whatever, it's not always apparent that people are aware of what Save the Bees means. I think they think it's just a catchy quip that they can just throw around and make them sound fashionable or like they care, like they're with it, right? And you can see in this picture, you've got a lot of signs here. You've got this black and yellow motif, and you've got a guy with antenna on his head, and it's like, that's not always what bees look like. So I do want to talk about, even just what is a pollinator to begin with. And in the research world, a pollinator is any animal that could potentially transmit one grain of pollen, a single grain, from one flower to the next. And that's it. It doesn't have to be good at it. It doesn't have to happen all the time. It doesn't have to be doing that as its intention. It just has to happen sometimes. So your dog, Sparky, running through the woods is technically a pollinator. So when people say, save the pollinators, I don't think that they have that in mind. But the pollinator world does encompass a lot of different types of insects. You've got a wasp. You can see some pollen grains on the back of this paper wasp right here. Butterflies, of course. People really love butterflies. And mosquitoes. Again, when people say save the pollinators, I highly suspect that they're not talking about saving the mosquitoes. But you can see all of the pollen on this particular mosquito here. Great pollinator on goldenrod right there. But bees are special. In the world of pollinators, not every pollinator does the same amount of work. There are some that are just, and it's kind of like any job you get into, right? Sometimes you see people who work really hard. Sometimes there's not necessarily people that are pulling the same workload. And bees pull the most workload of any other insect, possibly any other animal. They're just really, really good at what they do. The one exception being plants that require a specific type of insect to be pollinated, but in general, bees are going to pull a massive workload. So again, we talked about what pollinators were. Let's talk a little bit about what bees are, because there's some confusion again about what exactly is a bee. Bees are wasps. A lot of people don't realize this, and you can kind of sometimes see this online. That you see, this is a wasp, this is a bee, or I like bees and I don't like wasps. Saying you don't like wasps, but you like bees, is like saying you don't like dogs, but you like golden retrievers. It's like one is a group of the other. And that's what you can just see here. Like at this is the ancestor of wasps. You can see right here. And then all of the bees are the descendants of this ancestor. So they're just a smaller group within the group of wasps, the larger group of wasps. But they're different. They're a different kind of wasp, right? So they're vegetarians. Other wasps are going to get mostly their protein from insects or occasionally roadkill, but they're getting protein from a non-flower source generally. There are some wasps that do collect pollen. Bees almost exclusively collect their protein from pollen. And so they're what you consider like maybe a vegetarian wasp. So that's what they're doing. And the bees are not collecting pollen to pollinate flowers. They're collecting the pollen for themselves. They're collecting the pollen to feed their offspring in the same way that these wasps are collecting this wasp is collecting the cicada, for instance, to feed its offspring. It's not even really going to consume it itself. It really relies mostly on nectar. Same thing with bees. They're going to rely on these carbohydrates, but they need the protein for their brood, for their young. The other difference between bees and wasps is that bees are super hairy. Now, some wasps do have hair, but bees have very special hair, and this is what separates them from other wasps, because they have these hairs that are specifically evolved for collecting a maximum amount of pollen. You can see this hair, it's feathery, right? It's branched. All of those hairs are tools for collecting pollen, again, to suit its vegetarian lifestyle. And you can see just how well those hairs work. This is a ground nesting bee, and you can see it's just covered in pollen. That is so much more pollen than you saw in the mosquito, the butterfly, the wasp. Almost nothing else will look like this, covered in this much pollen, than a bee. Bees are really, really good at it. But in a lot of ways, I really like to think of bees as hippie wasps, right? Because they're vegetarians, right? They like flowers, they want you to save the earth, and they're super hairy. So they fit kind of the full bill of what it would be to be a hippie wasp. However, bees are incredibly diverse. So they don't always look like that black and yellow that we associate with bees. Maybe we are accustomed to thinking about bees like the Honey Nut Cheerios bee, or maybe like Winnie the Pooh in the honey hive. But they're a very, very diverse group of organisms. And you can see this is the smallest bee in North America, perched on the head of the largest bee in North America. That's how large the variation in size between bees is. There is about 20,000 species of bee worldwide, 4,000 to 5,000 species in North America, with about 365 or so species of bee here in Massachusetts. So a single bee for every day of the year. That's how many different bees there are in Massachusetts, North America, and worldwide. They can look like this is a European honeybee. Honeybees are not native to our area. They pretty much go wherever people go. This is another bee, right? This is a bee, it's called Megachile latmanus. And this is a male, and it's super, you can see it's super fuzzy, right? I took a picture of this bee on milkweed last year.
He looks like he's part tarantula.
Yeah, he's fantastic.
Like, oh my God.
This is a bee. A lot of people will say, oh, that must be a wasp, or that must be a flying ant. But look how furry these legs are. So those hairs are not necessarily always on their back or their forelegs. They could be on their bellies. They can be on their legs here. And not all bees are hairy. There are some parasitic bees that have virtually no hair, but a lot of bees you can kind of use that rule of thumb. When you're looking at an insect, it's not necessarily the color scheme, but what the hairs that they have. This is another bee here. That looks even more like an ant or more like a wasp. This is a small carpenter bee. And this is not a carpenter bee that's going to nest in your porch. This is going to be a bee that nests within the stems, within the cavities, within stems of plants. And this is a sweat bee, the pure green sweat bee. And you can see it's really shiny. That's not black and yellow at all. And this bee is really, really tiny. It's not, most of these bees, the other thing about most of these bees is that they're not social. They are solitary. Over 3/4 of bees are solitary. And so what does that mean? Well, some of them will nest in communities, like this bee right here. This is the unequal cellophane bee. And you might be seeing this bee emerge right around now in certain areas, coming up from the ground. It will nest in communal areas where you might have a strip that might stretch from this wall to this wall, and they'll all be holes of this bee. But within each hole, the queens don't work with each other. So there are not really queens, but the females don't work with each other. They do all of the provisioning and all of the care for their brood and all of the egg laying all by themselves. So there are no workers. There's no drones like you might have heard in honeybee hives. There's no queens. It's just a single female. The males are kind of like the guy your mom warned you about. They just really serve to reproduce, and then they go off on their own, and they leave the female to do all of the rearing and all of the work and all the feeding all on her own. And she doesn't have a lot of time, but she gets it done. So that's 3/4 of all bees, over 3/4. About 15% of bees in the northeastern United States are specialists. So what is a specialist bee? Well, a specialist bee is a bee that pollinates just a single small group of flowers. So this bee right here, it only goes to blueberry. So if you don't have blueberry, you don't have this bee, right? This bee over here only is a specialist on asters, which is a pretty large family of flowers, but it only will pollinate asters, and that's it. It won't really survive on any other flower. And about 15% of all of the bees in the northeastern United States are that. Or no, sorry, yeah, the northeastern United States. That's about 61 species. There are a bunch of memes about what exactly bees are and about their importance. And I'm kind of like this guy right here. I'm like, actually, this isn't really true, because when I know something, it's very hard for me not to want to teach people about it. And that's why one of the reasons why I'm happy to be here is I'm really happy to teach people about something I'm very passionate about. And when I see a meme or an infographic like this, it's hard for me not to just kind of point out all of the flaws within this infographic. For instance, these statistics down here, 1/3 of all the food we depend on, all the food we eat depends on pollinators, or more than 100 types of crops are pollinated by bees. They're mostly referring to just the honeybee, right? So all those other bees that we were talking about, the pure green sweat bee, the small carpenter bee, the Megachile latmanus, all of the 364 or so species of bee, these statistics are not really dependent on that particular bee. However, this statistic, about 85% of plants exist because of bees, that's mostly with reference to the native bees. So you can see it's really two separate stories. So when people talk about saving the bees, it's really important that we separate whether or not we're focusing on native bees or honeybees that are not native. And the reason that's important is because honeybees and native bees require different things and require attention paid to different aspects of their development. For instance, honeybees are effectively cattle because they're domesticated. They require an extensive amount of human intervention, and they cannot really survive very well without people taking care of them. They're a lot like maybe any domestic animal, like a cow or a goat or a sheep or a chicken. So when people talk about saving birds, they're not really talking about saving chickens, right? So when we talk about saving the bees, we don't really want to be talking and focusing on saving the honeybees. In addition, even though we do have hive losses of honeybees every year, honeybees are really in no danger of going extinct. They're on virtually every continent except for Antarctica. I believe they're not on Antarctica yet, but they're on most of the continents, right? And apart from North America and Europe, in most other places they're doing quite fine and actually increasing. So if you go to places like China, where you have tons of pollution, honeybees are doing perfectly well, perfectly fine. If you go to some place like South America, honeybees are doing perfectly fine. So it's one of these things where, again, what do we want to focus on? On the other hand, our native bees, for which North America is the only place that they exist, they're the ones that need our help, and they're not going to require, again, the same things. They don't require as much babysitting and human intervention. What they require is more us to just think about them a little bit more when we're going around and we're landscaping and we're working in our yards and we're doing all these things around. Just to think about what would a bee want, right? And maybe you can't make that step yet, but I'm hoping at the end of this presentation that you at least start to consider it. And I've got another chart to just kind of demonstrate and kind of hammer this point home about how important honeybees are for agriculture, right? So this is a pie chart adapted from this study from 2016 where they looked at total crop pollination services on a particular farm, right? What they found is that honeybees made up 39% of all of the pollination going on there. Every other bee combined, so hundreds of other bees combined, only made up 23%, right? So you could lose every single other bee and you'd still be just fine just based on the honeybees alone, right? But if you lose honeybees, well, now you need all of these other many hundreds of different species. And then all of the other insects that we talked about, the flies, the wasps, the butterflies, beetles, all these other insects that might be pollinating crops, they still did less work than the single species that is the honeybee. So honeybees are the most important crop pollinator. But again, they're basically like domesticated animals. You can think of them as cattle. On the other hand, our native bees evolved alongside flowers, and the relationship between bees and flowers dates back 70 to 130 million years ago. So you can think like what about North America? What about the plants and the bees evolving in North America for millions of years? Their relationship is very, very tight. What happens with one greatly can impact what happens with the other, right? And so we need to start thinking about this relationship between the native plants that we have and the native bees that we have. 78% of native flowers need native pollinators. And the other graphic, it said 85%. This says 78%. It depends on what study you're looking at and what geographic location you're looking at. This data is being taken from North America. So it's about 78% of the native flowers in North America need native pollinators. And because of this, and because flowers, they can't just get up and walk. They can't, if you wanted to start a family or meet someone, you might do some online dating or speed dating, but you could get up and walk and meet someone, right? Flowers can't get up and walk and meet anyone, right? So they are reliant on this vehicle, this insect, carrying that pollen from one of them, one individual, to another. And you can see that in this lady slipper, this has a pretty ingenious design where we like it the way it looks, but the petals of this lady slipper are tight, right? And we believe that the only thing that can pollinate this lady slipper here in North America are large bees. Bees like bumblebees, where they may be lured in with the promise of maybe some nectar or something inside, but there's nothing really in there for them. And the only way for them to get out is by pollinating the flower in the top, by coming out the top and pollinating that flower. So it's a trick, it's a trap for the bees to go in there. But the smaller bees, the really small ones, we don't think play any noticeable impact on pollinating these lady slippers. But flowers have designed some pretty clever means of tricking bees and luring them in. And they usually do so with the promise of food, right? So you can look at this flower. If you imagine yourself as a bee flying through a landscape, and it's mostly just this sea of green, maybe some brown bark, and you don't necessarily know what you can eat, right? It's like I'm driving down the highway, right? And I'm hungry, I'm looking for food, and I see a giant McDonald's sign, right? That's gonna tell me, oh, there's food over here. And that's exactly what a flower is in this landscape. In this sea of green, where you might not necessarily know where to go, you're a bee flying through and you spot that flower, and now all of a sudden you know where to get food. Things like the visual characteristics, the color, the shape, even these little folds on these petals, right? These are all characteristics that bees will cue in on. In fact, if you modify this flower so it doesn't have those folds, that bee may not necessarily go to that flower. It may not necessarily know to eat. And there are some bees, if you provide them with nectar, they won't eat it. But if you take a little petal and you put it next to that nectar, the bee will start to eat. It's important for those bees to have those characteristics. The way it feels, and they don't really have nerves like we do, they can't really feel, but when the bee lands, the petals may kind of depress at in a certain way. It might cushion them in a certain way, and they might be able to probe or feel with their hairs. All of these things might tell them that there's food available. And the way that the flowers smell, of course. So the flower is going to be emitting scent when it has nectar to provide, and you might even be able to notice that certain flowers might be less fragrant if it's really dry, because they might not be providing as much nectar for the area. So even the flower is conserving resources, knowing that there's nothing that it can provide to that particular bee. Flowers also have special designs that we like to call nectar guides. You can look at this painted trillium. There's a flower longhorn beetle right here. And this painted trillium has this striking pink, almost like a bullseye, like a landing pad, telling that bee where to land. So you can see all of this green and then white and pink. Very, very striking. And some of these nectar guides aren't even guides at all. What they do is they manipulate the pollinator to not just go straight for the nectar, but to cause that pollinator to walk around in circles. And you can think, with the anthers pointed outward and the stigma over here, this flower doesn't want the bee to just go directly and get the nectar reward or get the pollen. It wants that bee to stay on that flower for as long as possible, brushing up against everything, all these different plant parts, pollinating that flower. And that's exactly what these nectar guides do. They confuse and they manipulate this bee to walk around and pollinate that flower. Here are some examples of just how varied certain nectar guides can be. You can see some over here. You can see some right here, some right here. This one almost looks like a landing strip right there, just guiding that bee in. And the nectar guides actually extend beyond our own visible light spectrum. Most bees see in the ultraviolet, green, and blue spectrum. So when you take this flower, like a Rudbeckia here, like a brown-eyed Susan or a black-eyed Susan, and you shine ultraviolet light on it, you get nectar guides that we would never be able to see under normal circumstances. So what that landscape, what your yard looks like to you, looks very different to a bee. Bees and flowers also can interact with each other based on electrical signaling as well. Bees tend to be more positively charged and flowers tend to be more negatively charged. And we used to think that this was so bees were more efficient at collecting pollen. In addition to all those branched hairs, they could land on a flower and like static electricity kind of pick up all the pollen. And we're like, that's good enough. That's why the bees are charged this way and that's why the flowers are charged this way. But we learned that bees can actually detect and remember electrical signals on flowers, the specific electrical charge on a flower. So different flowers are going to have varying rates of charge. And bees can actually remember, and if you're a social bee, you may actually even be able to communicate that with the rest of your hive so that the other bees know how to recognize that, not just based on the appearance of it, not just based on the scent, but based on that electrical pulse. So if you think about a bee flying through a landscape and it's being pulled by flowers in different ways, that flower, knowing that feel of that flower as you're flying through, that electrical charge, that bee will be able to remember that. Remember, that was a flower that had a lot of pollen and a lot of nectar. It was a very good flower. Flowers also respond to the presence of bees. Flowers will, based on the electrical charge of the two, right, will emit a plume of odor as a bee approaches. So in this way, producing nectar and producing pollen and producing all these odors is actually very taxing on the plant. It's expensive. It costs a lot of resources. And the flower doesn't just want to emit a plume of scent any old time, right? They want to do it when they can really draw in that bee. So they're not going to do it when there are no bees flying around, but when a bee approaches and it can feel that electrical pull, right? That flower will emit that plume of scent and draw in that bee. So all these things are going to overwhelm the senses of a bee, so it's unmistakable that that flower is something that bee wants to go towards. Bees even have special behaviors that are associated with certain kinds of flowers. This flower here has what we call poricidal anthers. What that means is that inside this, what looks like a yellow banana, but it's actually the poricidal anther, it's a sheath. And inside is the pollen, like a little bit like a salt shaker. And bees, bumblebees in particular, will engage in something called buzz pollination, where this bee is actually vibrating its body to shake the pollen out. And bees are some of the only groups, they're the most well-known group of bees for doing this, and they do so by disengaging their flight muscles to shake their bodies. And you can hear this when you're in the garden. If you notice a bumblebee flying around, it will fly at the hum of a bee in flight is a certain frequency, and the buzz pollination is a different one. You'll be able to notice it. It'll be a higher pitched, almost like I'm thinking about my electric shaver, but it sounds almost like that. And so that you can see that shaking that pollen out. And this particular plant is not very easily pollinated by any other type of bee. Here's an example to highlight just how closely tied in bees and certain bees and certain flowers are, and how they can overcome the challenges posed. This bee right here is called Dionomia triangulifera. I know it's not a nice, catchy name. And this is Helianthus annuus. This is a sunflower, right? This bee likes sunflowers. It's a specialist on sunflowers. It's only active for 24 days out of the entire year. So you will only see this bee flying around for 24 days out of the 365 days of the year. And it produces, at most, 6 offspring. So this female bee, that male bee just left her, she's got a lot of work to do in just a short amount of time. And she's got to lay all those 6 offspring. So what does she do in order to maximize her time on this planet? She forages early in the morning during peak pollen presentation of sunflowers, when the sunflowers are presenting the most amount of pollen. And she synchronizes her nesting with the peak bloom of sunflowers, so that way all of her daughters and her sons will emerge during the peak bloom of sunflowers, this particular sunflower. And so that way they can get the job done in just that very limited amount of time. And this happens, if everything goes according to plan, this will happen every single year, right? But if there's ever a mismatch between that, like let's say the sunflowers bloom a little bit too early, or maybe she emerges a little bit too early or a little bit too late, or maybe the sunflowers were pulled up one year, that's going to really throw off her dynamic and everything she's trying to accomplish. So kind of on that note, right? Despite their many amazing adaptations, bees are in trouble. They need our help. And I know this is just one study out of a myriad studies demonstrating that bees need our help, right? There are so many studies that demonstrate that. But I like this chart a lot because it's fairly easy to follow. The black bar is the abundance of bees in the 1970s. The gray bar is the abundance of bees in the early 2000s. If the gray bar is higher than the black bar, the population went up. If the gray bar is lower than the black bar, the population went down. So it's really easy to see. But what you can see from this is that some bees went up. They're doing fine. Some bees didn't do so well, right? And so that's the picture, right? Is that when we talk about bee declines, we don't mean every single bee. So when people go out in their yard and they're like, bees are doing fine, I've got tons of bees in my yard, but which ones do you have? Do you have the ones that are doing fine everywhere, or do you have the ones that are not doing so fine? And when you look at the big picture, what you'll find is that most of the bees have decreased. Some were not found pretty much ever again, right? So that's what we're talking about when it comes to bee declines. It doesn't mean every bee. When I go to people's houses and they want to show off their pollinator gardens, they're really excited about them. They're like, I have so many bumblebees. I just don't have the heart to tell them it's all Bombus impatiens. And Bombus impatiens is everywhere, from Boston Common to Miles Standish to pretty much everyone's backyard. I find Bombus impatiens in the most polluted, pesticide-ridden environments. It's like the gray squirrel of the bee world. It just is highly adaptable and generalized and pretty much goes everywhere, very well adapted to man-made anthropomorphic, I'm blanking on the word, but man-made changes, right? So this bee you're going to find in a variety of different locations. So what are some things, and believe it or not, last year, so this is Bombus fervidus. One of the pictures I showed earlier was Bombus fervidus, and I have been finding that bee a lot more consistently in recent years. I'm hoping that this push towards helping bees and planting these pollinator gardens is getting this bee to come back, right? What is something that you all can do to assist with that effort? You know, what is something that you have control over, right? Because we can't necessarily always just ban every pesticide. We can't tell everyone to do everything, but we do have full control over our own backyards, right? The picture, what is driving bee declines, is actually fairly complicated, but the solution is very simple. If we can just start by adding habitat to our own backyards, and then we can do that on a larger scale. Like if you do that, and you do that, and you do that, and we all do this together, it doesn't matter if we're doing it perfectly or if we're doing it kind of like half-heartedly. If we're all doing a little bit on a large scale, that's going to benefit bees very, very greatly. Why is it important that we start rethinking about our lawns, right? The American lawn is effectively a desert for insect life. You get the beetle grubs, and that's pretty much it. Not a lot of stuff likes the American lawn. There's not a lot that grows in here. And it's kind of one of my hot takes. I actually don't think that the idea of no-mow May is really a thing that people should be focused on. Because at least in my particular yard, when I don't mow it, I get a lot of invasive plants. Things like hairy bittercress, things like dandelions, like clover. And a lot of the generalist pollinators, like Bombus impatiens, they like that. So when you don't mow your lawn, you're not necessarily helping out the specialist bees or the ones that are very sensitive to man-made changes. You're assisting more of the generalist pollinators that might be going to these lawns, right? What's something that you can do if you wanted to kind of replace your lawn? You could focus on adding more flowers, right? Adding more plants. And you want to focus on native plants. So we're talking, again, the relationship between native pollinators and native plants. Not everyone wants their yard to look like this. I've got 2 kids at home. We just had an Easter egg hunt last Sunday. And if my yard looked like that, I'm not quite sure. I think my kids would still be looking now for the Easter eggs because it might be pretty hard to find them in all that. That's great. Maybe one day when I retire, my yard will look like that, but not right now. So what I want you all to do is think about not necessarily doing the perfect thing or the best practice or the ideal. The real honest ideal is for you to just move out of your house, have it bulldozed, and donate your land to conservation, because even having your house is something that could be bee habitat, right? So what you're going to find is you're going to want to do the thing. Think about what your comfort zone is, right? What are you comfortable with changing around your yard or adding to your landscape? And do just a little bit more than that, right? So like, let's say you do like having that nicely clean, manicured, true green lawn. If the only thing that you do is have a little bit of milkweed grow up in your yard in a back corner, great, that's awesome. I want you to all think about giving back to bees like a donation, right? You give what you can. You don't have to give everything, but you give within your means, right? Some people are going to be able to give $1. Some people are going to be able to give $100, $1,000. You give what's within your means and stop thinking about what is the perfect ideal, right? Here's a compromise. You've got some native flowers here, and you've got grass right here. That's something that can be done. I mean, you've got a nice place for people to walk, for people to hang out, maybe for people to have a picnic or a barbecue, but you're still providing habitat for pollinators. And then maybe in future years, you could even move that out even a little bit more. So this would be a good example. So you want to find that compromise between this best practice, moving out of your house and living in a pod, and just perfectly manicured nothingness, desert landscape, right? So for every single person, it's going to be different, right? And so if your neighbor does less than you do or more than you do, don't feel bad or don't necessarily make them feel bad. They're doing what they can. The most important thing, I'm going to say it again, is to foster natives. These are some pictures taken from around my yard. I've got some black cherry, some choke cherry. I've got some sweet black gum. I've got blueberry. And there's going to be pollinators coming to these. These are not necessarily like plants you might find in a pollinator garden. Some of them are trees. And believe it or not, right now, this early in the season, the most important pollen sources are coming from trees. Another reason why No Mow May, to me at least, is kind of more hype. And also, you don't want to stop. You don't want to just wait until May. You would want all of those flowers to persist June, July, August. So there's not really a cutoff point. So I have a lot of issues with that trend. In any case, trees are very, very important for providing pollen sources. You've got willows that's blooming right now. You've got red maple that's blooming right now. You've got all of these different plants that are blooming. In fact, in the Pacific Northwest, there was a study that found 57% of bees were found carrying willow in the spring. So if you think about willow being hugely, hugely important for bees, not your dandelions, but if you can afford to put willow, like it doesn't have to be a full weeping willow tree, because I know that not everyone can have that in their yards. It could be like a shrub. It could be anything, right? It just has to be in the genus Salix. Here's some other examples of some smaller flowers that I have, some of the spring ephemerals. I've got this is a bog violet right here. I've got wood anemone, Canada mayflower, starflower, cinquefoil. These are all really small, inconspicuous flowers, but they're all native flowers that are going to support native pollinators. We also want to avoid any cultivars just to be safe. I want to ask a question, right? Who here was confused when they decided to change all of the exit numbers? That is effectively a cultivar, right? Someone, somewhere, decided to change something because they liked the way it looked, and everyone else on the highway was like this. Like, what in the world? It does not make sense. You don't even go like exactly in order. You're doing it by like mile markers or something. So like, where did this come from? So if you're a bee, if you think that you're a bee and you've had this relationship with a flower for millions of years, it looks the same, smells the same, it it has that electrical signal that is exactly the same for millions of years. And then humans come into the picture and say, I'm going to take that flower and I'm going to make it orange. What do you think that bee is thinking, right? They're thinking, well, that looks kind of like what I saw, but maybe, is it okay still? What if you make it blue? What if you change the shape? All these things, all the changes that we make to flowers, we don't necessarily know how they're going to impact bees. At the very best, this cultivar is not going to do anything. The bee is still going to be able to recognize it, it's still going to be able to pollinate it, and it will be just okay. At the very worst, it's not going to know what if that's a flower that it can even go to. And the reality is that most of these probably fall somewhere in the middle, right? So anytime you're planting a cultivar or a non-native plant, you need to think, is this okay, all right? Is this something that I want to do if I want to support bees, right? So, what we do in my household, at least, is we have some of these cultivars and non-native plants, and those are for show, because gardening and landscaping still has to be fun. You still need to do, again, what's within your own comfort zone. And we have some of those. We've got like forsythia out front that looks great. Some daffodils that are coming up. They're non-native. They still look great. They're not supporting a lot of bees, but it still needs to look nice, right? And in the back, I've got my willows. I've got my cardinal flowers. I've got my milkweeds. I've got my bee balm. I've got my mountain mints all in the back. And I have those around the side as well. And so I have it mixed in, right? And so we're doing, again, operating within our own comfort zone. But when I plant something specifically for the needs of a native bee, I am avoiding cultivars and I'm avoiding non-native plants. Again, like these are some crazy changes. There can even be changes in the way that they smell. And this is just changes. I can't illustrate that in a picture, how something changes the way it smells. But you can see how much they change in color and appearance. If you decide to remove a cultivar or a non-native plant, you don't want to just pull it. You want to replace it. And that's really important, because if you just pull a non-native plant, like if you were just pull these dandelions, what that happens is that's going to leave a void in resources. Believe it or not, if you can think of the most evil invasive plant out there, I don't know if it's garlic mustard, if it's Japanese knotweed, that's actually still providing some form of resources for some organisms out there. Believe it or not. Not great, not a lot, but still some. So even if you get rid of those, you want something available that is blooming at the same time that is going to provide those resources. So don't just remove everything. Better yet, you want to replace it, and then you want to pull it, and then you want to pull the rest of it and change it. If you're overwhelmed, you can pick a starting point. These are just some examples. I've got some flower lists at the top, and I can send this. You can either take a picture or I can send this through email. Xerces Society is an invertebrate, so insects. It's a conservation organization. Native Plant Trust, they're New England Wildflower Society. They're a major organization dealing with native plants. This is UMass Dartmouth. This is a professor at UMass Dartmouth, and this is one of my colleagues that works for the state. So all of these are pretty good but they're all not 100% complete. They're all, you want to think of them as a starting point. So flower lists are not a cooking recipe that you can just add everything in and get all the pollinators. What they do is they give you ideas and they set up a good framework for you to then build on. For instance, we talked about how there are 61-ish species of bee in northeastern United States that are specialist. If you planted all of the flowers on this and all of the flowers on this, you would still be missing 29 out of the 61 species of specialist bee. So it's not complete, right? You need to keep adding on it, keep building. So if you all need an excuse to go out and buy flowers, here's your excuse. If you come home and your partner's like, why'd you spend $300 on flowers? You can tell them that your friend, the entomologist, told you that you were saving the world, and this is what's going to happen if you plant these flowers. So you're adding on, you're adding layers. The other reason we want to add layers onto this is not just to support different species, but it builds resiliency in the landscape. I noticed last year that milkweed did not do so well in a lot of areas, and in those particular areas where milkweed was the primary flowering plant in the summer, they did not have that many bees and butterflies. But in landscapes where they had milkweed and other plants blooming, things like mints, they still had plenty of bees and butterflies. So you want to layer these things to provide resiliency in the environment in addition to providing additional food for other bees. Here's just kind of an example of a bee that is very often neglected or forgotten. This bee, Andrena uvulariae, is a specialist on bellwort, and it's very, very rarely ever found on flower lists. This is bellwort. This is actually taken from my own backyard, sessile leaf bellwort. I don't know if I have this bee, but this flower gets pollinated every single year in my yard, so I'm hoping at some point I'll be able to get my own picture of this particular bee. If you want to know more about specialist bees and their associations with certain plants, this is a great website. You can see that he has the bees listed, the bees right here, the states that they're found, how rare or uncommon they are, when the bees are active, and what the flower they're feeding on or they prefer to feed on, located right here. So this bee right here, Andrena distans, feeds on geranium. So you need that, right, if you want to have that particular bee. Or if you do have that flower, maybe you have that bee. If you need another starting point, maybe the others are overwhelming, you can actually just make your own. I put together this list for a Boy Scout one year, and it's not the best flower list, but it's simple. And what it does is it provides food during the spring, summer, late summer, and the fall. So it's got a variety of food blooming all throughout the full season. And what it has is most of these plants are actually host plants for butterflies. So you're going to be attracting bees, you're going to be attracting butterflies. You've got violets and willows for the spring. You've got milkweed and mountain mint for the summer. You've got nettles and thistles for late summer, and goldenrod and asters. Now, a lot of people don't necessarily like some of these plants like nettles and thistles, and violets maybe even, but they are great. And mountain mint, the mountain mint, you will not regret planting mountain mint in your yard if your goal is to attract pollinators. You will get so many pollinators on mountain mint, it will blow your mind. This is a study that I thought was really important, in particular people who don't necessarily have a lot of time for gardening. This was a study conducted in Ohio, and they looked at degraded strip mines over a 10-year period. And they looked at what would happen if we threw down packets of seeds, one low diversity mix and one high diversity mix, and we don't mow, we don't fertilize, we don't weed, we don't do anything for 10 years. What's going to happen? And shockingly, or not so shockingly, diversity went down. Not all the flowers were able to maintain themselves throughout the full 10 years. And what they found is that after about 3 to 4 years, there wasn't much difference even between the high diversity mix and the low diversity mix. And diversity has started to decline after the first year of seeding. But at the end of 10 years, some flowers that they had planted at the very beginning were still around with no maintenance at all, right? So if you think about, if you're someone who is like, maybe you have this back corner of your lot, or maybe you're in a garden club or you work for an organization and you just want to throw down some seeds in an area that has nothing growing in it, maybe like a lot like a degraded strip mine, just to beautify it, just to make it a little bit better, maybe focus on some of these flowers. The ones I have bolded are native to Massachusetts, and the ones that are not bolded are not native to Massachusetts. But even the ones that are not bolded, Rudbeckia, there are some Rudbeckia species that are native around here. Helianthus, they're rare, but you can find some native Helianthus around here, right? The ones that are bolded, wild bee balm, foxglove beard tongue, that's a really cool looking plant if you've ever seen it. Erigeum annuus, right? So that's annual fleabane, and you've got wild basil. So all of these plants, you could just throw down the four-ish plants that are native to Massachusetts here, and that could create, that's better than nothing, right? And you don't even have to do work. You don't have to weed, you don't have to fertilize, you don't have to maintain. I don't know if it's going to be the same, if they're going to last the full 10 years like they did in Ohio, but we don't know that because this study was published in 2022 and no one's ever done the study in Massachusetts. So you could just start here. It's a good starting point. And these are probably very hardy species of flowers that probably do provide a good source of pollen and nectar for bees. But in addition to providing food for bees, you also want to be thinking about the full life cycle of bees as well. This is a ground nesting bee. You can see it tunneling into the ground right. I took this picture right in my backyard. It was just tunneling in at the exact moment I decided to take a picture of its butt covered in pollen. The reason you want to pay attention to the full life cycle of bees is because this is what we see, right? This is the blue orchard bee. We see it flying around, and we might think, oh, we've got a garden full of bees, right? This bee is only active for about 3 to 4 weeks out of the entire year. So what we see happens either in the month of March or the month of April, depending on where we live. Up here, we'll probably have more of the late flying population, so probably closer to April. And that's what we're going to see, right? What happens out of sight? The eggs, the pupa, and the adult, all happening outside of our vision, living inside a stem, right? So in your landscape, it's not just important to have flowers for the adults that are active during the 3 to 4 weeks that they're alive, but to provide stems and protect those stems in nesting habitats for the rest of the life cycle, that rest of the 49-ish weeks out of the year, right? Where do you find bees? 64 to 80% of bees nest underground. A good chunk of them are runters right here. The rest are going to be wood excavators and above ground builders, what we call this. So the renters are bees that are going to nest inside cavities, right? So that's, if you've ever seen bee hotels, they look almost like a birdhouse and they have a lot of holes in them. That's what we call renters. They're going to go into that and they're going to move into that and they're going to live inside the stems. They're going to live inside these tubes. Wood excavators like your carpenter bees. And then your above ground builders are, a lot of your bumblebees are above ground builders where they can nest in a lot of different locations. An empty hole in a tree. I've seen them nest in wood pallets that were covered in leaves. I've seen them nest in rodent burrows. They nest in a lot of different locations. So they're kind of like, they just kind of move into empty cavities, right? But most of them, you can't really do too much for these ground nesting bees. If you have them, you have them. The best you can do is if you see people who are concerned about them, just say they're only going to be active for about 3 to 4 weeks. And that's it, and they're not going to really sting you. It's very difficult to get stung by one of these bees. When I was taking a picture of this, this is how close I was to the bee. Very, very close. And I've never been stung by one of these. I've taken a lot of pictures of these. They've never stung me. How do you provide habitat for these renters? The thing that I recommend you do is not buy a bee hotel, but simply leave the real stuff behind. When people talk about saving the stems, we want to leave these pithy stems, things like raspberry, rose, sumac, all of these stems that kind of stick up. And what happens is some bees can actually excavate that and tunnel into it and create a hole in there. And then other bees will be able to nest within that stem. Some of the stems are sometimes hollow, and the bees are already capable of nesting inside. But the reason I recommend the real stuff is that this three-dimensional structure, right? It looks messy to us, but bees actually want it to be this way, right? Because a lot of these stems, they're sticking up, they're facing different directions, they're far apart. You know, we came out of a pandemic, and we all know about social distancing. This is social distancing in the bee world, right? They're far apart. If one of these tubes, if there's disease in one of these, it's not going to very easily spread between the tubes. If there is a parasite of bees that is looking to target bees and move in and parasitize the bee, it might move into this stem, but it might not be able to find the bees in the other stems around here. If you have a bee hotel and all those stems are facing the same direction, then parasites can move in between them. Disease can spread in between them. And so in a lot of ways, these bee hotels are a lot like, they're not really like a 5-star resort. You can see disease might be able to be transmitted very rapidly between all of these holes. And so this might be a little bit better, but in here, you don't really want that. And they're all facing the same direction, which is going to be a beacon for parasites. If you're a parasite flying in a landscape, you've just hit the jackpot when you've landed here. How do you build a bee hotel and do it what I would consider the right way? Well, what you want is if you look at this is a good model for how you would want to build a bee hotel. I would actually go one step further and have certain holes facing different directions so that you're not going to have that simple unidirection that the bees are facing, right? You want it to be, you kind of want it like closer to the tree line. You want it shielded from sun and rain. Each of these, if you look at the blocks have the holes. They're pretty far apart in terms of being spaced. Each of the tubes are about 6 inches long or 6 inches deep. And that's really important because what the female bees can do is they can decide whether or not they're laying a male or a female bee. They can decide whether or not they want a daughter or a son. And they tend to lay their daughters towards the back and their sons towards the front. And if you shrink that tube to about 4 or maybe even less than 4 inches, what happens is that mother bee may end up laying fewer daughters and the same amount of sons. So she may lay 6 bees total. If she has laid 6 bees total, she may lay 4 daughters and 2 sons. You shrink that tube, she may lay 2 daughters and 2 sons, or 1 daughter and 2 sons. So now you've shifted the population dynamics of what could happen in future generations. And the future generation is going to be mostly dependent on the number of girls that emerge, not necessarily the number of boys. So 6 inches deep is really important. And this, it's really great because you can see they're lined with paper, which means that these tubes are replaceable. You can pull them out every single year and replace them with new paper so that disease can't continue to build up within these cavities. So that's a really good, this is a really good, we can see here, they even have a separate thing for only 5-inch sections, right? For maybe supporting different types of bees, but 6 inches is a good rule of thumb. And last but not least, it's not all or nothing. If the only thing you do is plant, like this is some showy goldenrod, if the only thing you do is have some showy goldenrod in your yard, that's better than nothing. That's better than where you were before. Because what we know about bees is that it's kind of like a game of connect the dots. Honeybees and bumblebees can fly for several miles. But when we talk about those specialist bees, those tiny bees, the huge variety of bees, most of those can only fly for about 1/4 of a mile. Which means that you can be doing everything perfect, right? You can be doing everything well, and you may not get all of the bees. It's not going to be until your neighbors do it, and then their neighbors do it, and then those neighbors do it, that we can connect all of those dots together and create a habitat that is much wider than it was before. Which is why it's always better. You don't necessarily, it's good to do as much as you can, but it's better to get other people around you to do more, right? So a street with everyone doing just a little bit is going to be better than a single yard that is doing the best possible, right? It's better, like a single piece of conservation. Let's say you have a single pollinator garden. It's the best pollinator garden ever. That's not going to be as good as just convincing a whole neighborhood or a cul-de-sac to do a fraction of that pollinator garden. For additional reading, these are some great books to look at. If you get a single book, The Bees in Your Backyard is awesome. Common Bees of Eastern North America is just an identification guide. It's associated with this one. It's the same authors. Bumblebees of North America, great identification guide for bumblebees. And this one here, The Solitary Bees, Biology, Evolution, and Conservation. That one's great. So this reads a little bit more like a college text or maybe a graduate level text. It's got a lot of scientific data in here, but if you really want to take that deep dive down the rabbit hole, I highly recommend The Solitary Bees. Even though that's not going to include bumblebees and social bees, but it's going to focus on the 3/4 of bees that we have here. Last but not least, I'll take any questions at this point. Anything that you might want to know more about bees or maybe even pollinators in general. Could be about butterflies. I'm happy to entertain questions on that as well. Thank you.
You did very well.
Thank you.
Very much.
Thank you so much. Thank you.